All right, happy Tuesday morning. We're going to go back to another day of introducing exponential functions. And again, an exponential function is just any equation of the form y equals a times b to the x. The important thing here, you could have 2 times 5 to the x, or y equals 6 to the x. The important thing here is that you got an x in the exponent. That's really what makes it an exponential function, is that we've got an x in the exponent. That's the important part here. So, let's look back at how does this exponential function change? How does the y value, or this y column, how does that change in an exponential function? Well, in a linear function, and we know linear functions pretty well, in a linear function, I've got some line on a graph here, x-axis, y-axis. And I know it goes up or down at the same constant rate. So here from 9 to 13, I'm adding 4. Or from 13 to 17, I'm adding 4. 17 to 21, adding 4. 21 to 25, adding 4. So this is a linear function, because I'm going up at the same constant rate. I keep adding the same number every time. So then what's the difference when it comes to an exponential function? What's going on there? Well, here, I'm not adding the same thing. I'm not going up by the same, strict amount every time. But what's happening is I'm multiplying by the same thing. Or, depending on which direction you go, maybe even dividing by the same thing. So here, from 1/25 to 1/5, I'm multiplying by 5. And I could check that with a calculator. I could say, in my calculator, if I take 0.04 and I multiply by 5, do I get 0.2? And I do get 0.2, so I know that works. So always feel free to use a calculator to check all of these. Or from 1/5 to just 1, I'm still multiplying by 5. Or you could ask yourself, how many 1/5 goes into 1? So, if I had a pentagon block here, and I split it into 5 pieces, if I split this into 5 equal pieces here, then we could say, how many of these 1/5 pieces makes the whole shape? Well, it'd be 5 of them. 1, 2, 3, 4, 5 of those pieces makes one whole, or 1/5 goes into 1 5 times. And then 1 times what gets me 5? Well, 1 times 5 gets me 5. And 5 times 5 gets me 25. So this is exponential because I'm multiplying by the same thing every time. And this function is y equals 5 to the x. So yesterday I had you do a Desmos activity, And the reason why I made you do that is so that we could look at, this is 5 to the x. So we could say 5 to the x is negative 2, 5 to the negative second power over 1. And what do we do when we have a negative exponent? Well, we move that down into the other part of the fraction. We're kind of, I think Mr. Porth's analogy was we're grounding it. You're being bad, you're being negative, you get sent to your room, wherever your room is. So this is like 1 over 5 to the second, which is like 1 over 25. Or we could say 5 to the first equals 5. 5 to the second equals 5 times 5. So you can see here we just multiplied by 5 again. I'm sorry, I put that in the wrong spot. 5 to the first is 5. 5 to the second is 5 times 5. So we multiplied by 5 equals 25. So that's what we're trying to get at with these exponential functions. We're plugging in these values into our exponent. So this is 5 to the 0 power. 5 to the first, this is 5 to the second power. Okay. So again, notice how in that linear function we were adding 4 every time, but in that exponential function we were multiplying by the number 5 each time. So I want you to look at these 4 tables. I want you to ask yourself, is this linear? Am I adding or subtracting the same thing every time? Or is it exponential? Am I multiplying by the same thing every time? So let's do this first one together. 16, 13, 10, 7, 4. So what's my pattern here? How am I changing every time? Well, from 16 to 13, I subtract 3. From 13 to 10, I subtract 3. 10 to 7, I subtract 3. 7 to 4, I subtract 3. So if I'm subtracting or adding the same thing every time, then that's a linear function, which means that it's not exponential. It's linear. So linear, not exponential. All right, what about B? What's going on here? And if you're ever not sure, you can always start with 1, and you can see what's your pattern, and then see if it still fits going the other direction. So 1 to 7, I could add 6, but that pattern's not going to hold for my next step. I could also multiply by 7, and does that work? Is 7 times 7 49? That seems to work. I could also go this other direction. I could say 49 divided by 7 is 7. 7 divided by 7 is 1. 1 divided by 7 is 1/7. Or I could check in my calculator. I could type in 1/49th, and I could say, well, is that decimal times 7, is that going to get me 1/7? And it does. So don't feel like you can't use your calculator. You've got these resources. Definitely take advantage of them. You could always use your calculator back here, and you could type in 1/25 times 5. See if you get 1/5. You could type in 1/5 times 5 and see if you get 1. make use of these resources, definitely. Why don't you try the last two here, and then we'll talk about graphs. So pause the video, try these last two, and then unpause it. So let's see, 1/3 to 2/3. Well, I could multiply by 2, but then if I do that again, that's not going to work. I could also add 1/3. So 1/3 plus 1/3 is 2/3. Let's see, does that work? 2/3 plus 1/3 is 3/3. 3/3, is that equal to 1? Yep, so feeling good about that. Plus 1/3, so 3/3 plus 1/3 is 4/3, plus 1/3 is 5/3. Okay, well, if I'm adding the same thing every time, is that exponential or is that linear? Is that not exponential? That is not exponential. That'd be a linear function. And there are other not exponential functions, but we're really just focusing on the two here for right now. And here, let me start in the middle. Maybe I'm not sure about that. 1 times 9 gets me 9. 9 times 9 gets me 81. And I could try this in my calculator. That seems to work for here. And I'll check the very last one. 1/9 times 9 does get me 1. So I check in a calculator. I could type these two parts in and see if that works, and it does. So it looks like I'm multiplying by the same thing every time, which would mean that I have an exponential function. And our very last step here, again, we can classify these. We're looking for if I have an x in the exponent. So looking at A, I have an exponent, but is that x in the exponent? Well, the x is definitely not in the exponent, so that is not exponential. And I'll leave you guys these last three to do, but let's talk about graphs first. So exponential graphs, they build up very slowly in the beginning, and then they grow bigger and bigger very quickly, or they might shrink very quickly, and then they reach a point where they just kind of level off. And I always thought that these kind of look like a slide, a big water slide, maybe at Six Flags, where you start going down very, very fast, and at the end, you kind of level out before it shoots you out into the big pool. So let's look at these last 4 graphs. I want you to pause the video and see if you can classify these as exponential or not exponential. So A starts off growing very, very slowly, then it grows very quickly. There's just the one slide there. Looks like a water slide at Six Flags, so this would be exponential. B looks more like a roller coaster. So you can see it's not growing and then kind of leveling off. It grows, but then it shrinks again, so that's not exponential. Here, again, same idea. It grows, but then it shrinks, and then it grows again. So that's not exponential. And our last one here shrinks very, very quickly, but then it levels off. And it's that leveling off that tells me here that that is an exponential function. All right, so I'll need you guys to do your Google form. Again, that's your attendance for the day. Just a few questions.